Today we're going to be talking about the following problem in which we have a group of 150 individuals, and in these 150 individuals, 15 of them have a disease. A random sample of 10 individuals is being conducted, and we want to know what is the probability exactly 2 individuals in this sample have the disease. Okay, so we're interested in calculating this probability. So exactly 2 have the disease in the sample. Okay. Well, if we're going to calculate probabilities, there's a theoretical probability and there's observational data formula for calculating probability. Here we don't have any data, so we have to use the theoretical probability. The theoretical probability says it's the number of ways that the event occurs divided by the total number of outcomes. So in particular, if we have exactly 2 with disease, that means we have 2 out of 15 with the disease. Okay. Well, what about the other 8 people in the sample? Well, the general counting principle says we multiply by the number of ways that we get the other 8 individuals. Okay, so that means we have 8 individuals, 8 without the disease, from a population that has a size of 135 divided by the total number of outcomes. Okay, now um, I'll go through this just verbally here. So we have 2 out of the 15 with the disease. It doesn't matter whether you're the first person selected or the second person selected. If you have the disease, the order doesn't matter. So order doesn't matter. That must mean we're dealing with a combination. So we have 15 choose 2 ways of getting 2 people with the disease. Again, it doesn't matter whether you're first or second, so that's why we have a combination, times the number of ways we have 8 people without disease. Well, there's 135 people without the disease. It doesn't matter whether you're the first person, the second person, or the 8th person selected without the disease. It just matters that you don't have the disease and that you're one of the 8. So this is going to be 135, choose 8. And that's why it's a combination, because the order doesn't matter. You just need to be one of the 8. Total number of outcomes, there's no way of ensuring that the sample has exactly 2 people with the disease. It could have no people with the disease. It could have all 10 people with the disease. All you're doing is you're taking a sample of size 10 from 150. Doesn't matter in which order you're selected, just matters that you're one of the 10. So the total number of ways to select people is from the pooled population or total population of 150, and that you're one of the 10. So 150, choose 10. And that's how you will calculate this probability. Okay. One thing that this illustrates is the use of combinations to calculate this probability. And that was an essential aspect.